Welcome back to another Math Club episode on calculus. This one, we're going to be talking about something called the product rule. We can just talk a little more about derivatives as a whole. So I'm going to give you some problem questions to start off, just to check that you're with me. What is the derivative of 3x squared plus 2x minus 1? And what's the derivative of 5x plus 3x squared minus 2? And then what's the derivative of 6x cubed plus 17x to the 13th? Okay? And just as a reminder, this is some new information actually. The derivative of something plus something else is the derivative of the first thing plus the derivative of the second thing. Basically meaning if I'm doing the derivative of something like 2x plus 1, it's the same thing as the derivative of 2x plus the derivative of 1. And if I'm doing something like the derivative of 15x to the 4th plus 3x squared minus 2, it's the same thing as the derivative of each of the things added together. Like that. Okay? So these are your problem questions, and now I'm going to erase them. Please do the problem questions, by the way, because they can really help. Okay, so now we're going to talk about the product rule. Just as a reminder, if I have something like f of x, that means that your input is x, and then you have something like x to the n times e to the n x, e to the x plus 30x to the 5th or something. I don't know. It's just some function with x involved. And I also mean this when I'm talking about like g of x is like the same thing, and h of x. It's like the same idea. They'll all represent different functions. Okay. Say I have a square, that's g of x, by f of x. Now, let's go ahead and look at some small change in each of them. I know I'm drawing it really hugely, but that's just so you can see. So, right here is some small change in g. Right here is some small change in f. Okay? What is going to be the change in them being multiplied? Well, let's look at this. This is dg times f of x. So it's f dg, right? And plus, well, this is g by df. So g df. Now let's divide by dx on both sides. That's always helpful. So the derivative with respect to x of f of x times g of x, I'm going to add in the function notation now, is going to be f of x times g prime of x. What does g prime of x mean? Well, g prime of x is the same thing as the derivative of x. The derivative in respect to x of g of x. It's the derivative of g of x when I write g prime of x, right? Because if I'm dividing by dx, I have dg over dx, right? Make sense? So now, plus g of x times f prime of x. Okay? So a good mnemonic to remember this is the derivative of left times right is left d right plus right d left. What does this mean? Well, right here is d left, right here is d right, and by that I mean the derivative. So left f of x times the derivative of the right, g of x, g prime of x, plus right, g of x, times d left, f prime of x. Okay? So there's like a mapping right there. Okay? That's what I'm talking about when I say this. So what does any of this mean? Well, what it says is that if I have something like 2x plus 1 times 3x plus 5, instead of having to multiply all the way through, then take the derivative, I could just take the derivative of each one of these individually and use the product rule. So we could use left d right, derivative of 3x plus 5 is just 3, plus right, 3x plus 5, d left, which is just going to be 2. This gives us 6x plus 3 plus 6x plus 10. This gives us 12x plus 13. That's the derivative, and we didn't even have to multiply at all. Well, I mean, like we did this and this, but we didn't have to double distribute. We only had to single distribute. Okay? Now, let's talk about another thing that might be a little confusing at first. 1 over x, derivative of 1 over x. Okay? Well, we can rewrite this as x to the negative first, which we can then do the power rule, which is that x to the n, the derivative of that is n x to the n minus 1. So negative 1 times x to the negative 1 minus 1, which is negative 2. So it's negative 1 times x to the negative 2, which is then going to be negative 1 on x squared. Okay? You can do this similarly for the derivative of the square root of x. This gives you the derivative of x to the 1/2, which is then going to give you, 1/2 times x to the 1/2 minus 1, which is negative 1/2, which is then going to be 1/2 times 1 on square root of x, right? Which is then going to be 1 on 2 rad x. And there we go. That's the product rule and some more on the power rule. So if I were doing the derivative in respect to x of square root of x on x, you can actually rewrite this because x is the square root of x times square root of x, square root x times square root x. Cancel those out, you get the derivative with respect to x of 1 on square root of x. This is then going to be the derivative of x to the negative 1/2, and I'm sure you can figure it out from there. But you could also use the product rule, because square root of x on x is the same thing as square root of x times 1 over x, right? Now it's going to be the left D right, right here, plus right, D left. Which then gets you negative rad x on x squared plus 1 on 2 x rad x. You can then rewrite x squared as square root. You know what? Let's leave it as x squared on the bottom. Now you can multiply by this by 2 and this by x, or this by 2 rad x and this by x. So you get negative 2x on 2 rad x times x squared plus 1 on 2 rad x, multiplying it by x on top and bottom. You get this, which you can then simplify to negative x on 2 rad x times x squared. You can do that, and then you have this. That's your final answer. Now, what do you get out of this? We get negative 1/2 times x to the negative 3/2, right? Which is then going to be negative 1/2 times x to the negative 1/2 times x, which is then going to give you negative 1 on 2 square root x times x. Same thing, same answer, but using the product rule. And now I'm going to give you some problem questions. Sorry if that didn't make sense, but just to demonstrate a point. What is the derivative of, say, 1 on x squared times x to the 3/2? Number 2, what is the derivative of 3x times the quantity of 1 plus 2x plus 1? That's not right. What is the derivative of 4x plus 13 times 17x plus 11? And number 3, what is the derivative of 13x plus 8 times the derivative of 5x squared minus 2x? Okay, that's a little different of a problem, but I'm sure you can do it, and we're out.